you scared me. How long have you been standing there?
Oh, quite a while.
You've been standing there quite a while. I didn't even notice you. You know, frankly, I haven't seen you around for a while.
Why?
Well, I mean, you know, honestly, to tell you the truth, I thought you were dead.
Dead? What are you talking about?
Well, not dead, but you know, dead in the way that tape is dead.
Hey, come on, you're spinning this guy. I've been in the data center till the 60s. What are you talking about? I was serving your tier 1 applications for a long time.
Yeah, I mean, you had a great run, but, I mean, you're becoming less and less relevant in the data center today.
You need to explain that much more.
Well, have you heard about Wikibon? Have you heard about David Floyer?
No.
Okay, well, Wikibon is one of these analyst firms, okay, like Gartner or IDC. And David Floyer from Wikibon wrote this great white paper about flash storage and pretty much the recent history of storage. Do you know, you haven't heard of this?
No. You need to explain more.
Okay, let me see if I can explain. So basically, Wikibon, you know, this analyst firm, they took the recent history of storage, okay, and they characterized it in 4 generations. So obviously we're going to start in generation 1. And generation 1, this is the generation of the hybrid array. It's what we've been doing for a long time, for many years. It'll probably continue to be there for some years to come. So this is the hybrid array.
No, that's my place, you know?
Exactly, and what we're talking about here is, you know, technologies like VMAX, technologies like VNX. So these are arrays that are meant for spitting disk, you know, so a lot of you and all your buddies, right? And then there's a tier of flash that's been added to that. And then you have a software, like an automated tiering mechanism that moves the hot extents up to flash, and the colder extents down to lower levels of you guys spitting disks, 7.2 or 15K or 10K drives. And that's what we've been doing for some time now in the data center, right? So that's generation 1. Does that make sense?
Yeah, I know these guys, these SSD guys.
You know this really well. You've heard of SSDs.
Yeah, absolutely. They're fast.
They're very fast. They're a lot faster than you.
Yeah, I know. It's still right to be there, right?
You're a little insecure about that?
Huh?
Are you insecure about that?
I'm frightened a little, but...
Generation 1, right? It's the hybrid array. Okay, you're pretty strong.
Yeah.
Okay. So then Wikibon said, well, then we enter generation 2. Okay? So in generation 2, this is still the age of hybrid arrays, but this is what they're calling the flash optimized hybrid arrays. So you see where I'm going with this? Flash.
I don't know if I want to see more.
No, just hang with me just for a second.
Yeah.
You're still okay in generation 2. All right, so flash optimized hybrid array. So these are really companies like Nimble and companies like Tgile and Tintry. Now, it's still a hybrid array, but it's a hybrid array that's kind of built for flash. So the key here is that these guys made a hybrid array where flash was easier to consume. The software that was associated with these devices was easier to consume, right? So ease of use, ease of management, and ease of deployment were the main benefits of the generation 2. But where the generation 2 fell short was it was just basically a baby step improvement from generation 1. It was still dual controller, so performance was good, but it was okay. It was just a little bit better than generation 1. And since it was dual controller, it was targeted for a single workload. You couldn't mix different workloads on the box.
Yeah.
And it was geared mainly for the smaller end of the market. So scalability was a big problem in generation 2. So it's not a technology that could be adopted broadly within the data center. It was mainly geared for the smaller end of the market. So generation 2, we really call this the generation of insignificance. Forgot how to spell. Okay? So that's generation 2. Do you have any questions on that?
No, I'm still there.
You're still there. You're still there. You're hanging on.
Yep.
Okay? But now, Wikibon said we enter generation 3. And in generation 3, this is when we see the first iteration of the all-flash arrays, right? So I'm sorry, no spinning disk. It's all SSDs. It's all flash. So the all flash arrays, okay? So in Generation 3, there's really two pieces of Generation 3. There's the early Gen 3, and then there's the later Gen 3. Now in the early Gen 3, we saw companies like IBM with their acquisition of Texas Memory Systems, and we saw companies like Violin. And what these guys did was they built a fast box. So they took that box that was meant for spinning disk, and they basically took out the spinning disk, they took out all you guys, and they threw in flash, right? So it was a fast box, but it had no data services. And now, as you know, flash is still more expensive than spinning disk.
Yeah.
From $1 per terabyte, $1 per gigabyte perspective. So you need data services, you need compression, and you need deduplication in order to reduce that cost of flash and make that product more consumable in the data center, right? But these guys had no data services outside of data protection and no data services. So again, it's not a solution that could be adopted broadly within the data center. And it's still dual controller, targeted for a single workload. So you could deploy it over here for like a small VDI deployment where cost was not an issue and you just wanted to throw performance at the problem. But it's not a solution that you could build an all-flash data center with. It could not be adopted broadly within the data center. Does that make sense?
Yeah, okay, I get it.
So then that was kind of the first phase, or early Generation 3. Later Generation 3, we started seeing companies like Pure and companies like Whiptail, which is now Cisco. And what these guys did was they took that fast box that the early Generation 3 guys had, and now they added data services. So they added dedupe, they added compression. And that was good because it lowered the cost of flash. But the problem is they added it in a way that also degraded performance. And worst of all, caused unpredictable performance. Because they added those processes as a post-process. So they're storing all the data, and then there's a background process that eliminates the copies and dedupes the data. Or they're storing all the data, and there's a background process that compresses the data. So if you're doing it as a post-process, then you're running it on the controller. And that's a heavy, heavy process to run on the controller. If that controller is busy with these background processes like dedupe, like compression, like system-level garbage collection, then it doesn't have as many cycles to serve up I/O up to the host. So you get degraded performance and also unpredictable performance.
You see, the latency will be just like me, right?
The latency will be disk speed.
Yeah.
A year down the road or 2 years down the road as system-level garbage collection kicks in, right? So the flash is going to perform like spinning disk. So if you're in Generation 3, Generation 3 is really the generation of compromise. If you were in Generation 3 as a customer, you had to pick. You had to choose between a fast box, but no data services, so high cost, and a point solution. Or you could add the data services and reduce the cost, but also suffer from degraded performance and unpredictable performance and unpredictable latency. Not that's dissimilar from spinning disk. Okay? So does that make sense so far?
Yeah, yeah.
Okay. But then, Wikibon said, well, in about 2013, we entered Generation 4. And in Generation 4, this is the generation of XtremIO. And XtremIO is completely different than the previous generations. It's an all-flash array, but it's scale-out and inline data services. So with scale-out, whereas these were dual controller, you had a controller A and you had a controller B, you could add capacity, but you couldn't add performance, right? So you couldn't scale and performance, you had to buy a new box. So, and when you add capacity to those same two controllers, you're putting more of a load on those two controllers, and that's how you get the degraded performance and inconsistent performance as you scale up within this architecture.
I know scale-out. Scale-out is enterprise, right?
Scale-out is enterprise. So
Yeah.
with scale-out, we have we deploy our solution in Lego building blocks, XtremIO. You have an X brick that has 2 controllers and 25 SSD drives, and you can start small. You can start as small as a 5 terabyte block or a 10 terabyte block. And as you need more capacity and performance, you just add X bricks.
That's cool.
Yeah, and each time you add an X brick, you're doubling capacity and you're doubling performance. So with scale out, it's really ideal for an enterprise class data center where you can take mixed workloads, you can take all of your tier 1, tier 2, tier 3 applications and throw them all on an XtremIO cluster. So it's a solution that you can build a complete all-flash data center with. And then the data services. So we have dedupe and we have compression, but it's never post-process. It's always in line. So we're only landing unique, compressed, deduplicated 8K chunks on the array. So if we're doing it in line and not post-process, we never run those processes on the controller. So you'll always get predictable performance. The way the array works on day 1 is the same way the array is going to work a year down the road, 2 years down the road. You're going to get sub-millisecond latencies at all times, whether the array is empty or it's completely full, whether you're with 1 brick or you're up to 6 bricks, right? So with XtremIO in Generation 4, this is really the world of no compromise. With Generation 4 and XtremIO, you can really have the best of both worlds. You can get the performance, predictable performance, and the low cost, the low TCO with the data services. So I'm sorry, but now that we're in Generation 4 and we have XtremIO, the world of spinning disk, it just doesn't look good for you.
I see what this will end, so yeah.
I'm sorry.
What's
man.
nice with you guys?
It's been a good run.
Yeah.
It's going to be a good run.
I'm sorry. I think I have to leave.
It's time for you to go, my friend.
All right.
I'm sorry.
Yeah.
All right.
See you in the archive, right?
See you later, man.
Yeah.
I guess I won't see you later. I guess this is goodbye. All right.
Maybe there's some place in the archive still, right?
Maybe. All right, later. Bye-bye. Okay. Well, I think I just got Gen4 certified. Now I want to throw the challenge out to the other core teams here in Los Angeles. Particularly, I want to throw the challenge out to Pete DeAngelis and his great team of sales reps and SEs in the El Segundo district. I hope you guys join me in getting Gen4 certified as well. So, thank you.